Alright, so I am going to do a demonstration on how to uh, draw a fairly simple roof, but with a couple of things that make it more complicated than just a standard uh, roof. Let's say we've got a building that's shaped like we've got here, these white lines, and the clients want to have 10-foot ceilings throughout, but there's going to be a 13-foot ceiling in the front, and they want 10 and 12 pitches on the sides, and that's just to make it look nicer from the street. But then they want 6 and 12 pitches on the front and the back, and that would be to maybe save some money to keep the roof from being so expensive. So we've got a couple complications here. One is we're going to have unbalanced hips and some unbalanced valleys, and also some different plate heights. So the first thing we have to do before we can start drawing any of the roof is determine how we want our overhangs to work. So what we have to do is, over on the side, we need to draw a 10-foot plate with a 6 and 12 pitch, and then a 10-foot plate with a 10 and 12 pitch. So the way you do this fairly quickly is just come over here somewhere on the side and draw 121 inches, because they're actually 10-foot 1-inch plates. They're actually like 10-foot 1 and 1/8, but forget the 8. Over 4 inches and then back down. So this represents the plate, the stud wall with the bottom plate and the top plate. What we're going to do is just come over here and go 12 inches and then up 6 and then close it, and do an offset of 6 inches. That's the rafter and the 1/2-inch plywood. And we'll worry about the overhang in just a minute. That is the 6 and 12 pitch. Let's do the 10 and 12. 121 inches, 4 inches, back down. And again, we're going to do a opposite just to make it easier to see in a minute. 12 inches, 10 inches, close. That's our pitch for the other side, the sides. Offset that by 6 inches. And so now we have to figure out our overhangs. And what you'll notice is, because of the different slopes, the overhangs cannot be the same. If they were, there'd be problems. So typically for the 10 and 12 pitch, we're going to want to have a smaller overhang. Let's just start with 12 inches and see what that does. We'll go to this point. If you're going to do a 6-inch fascia, then just do 6 and then over. I know this is a very simplified version of an overhang, but for what we're doing, that's all that matters. And then we want the fascias to be at the same level. And so if we extend this over and draw the same 6-inch, we can see that again this one was a 12-inch overhang. This one ends up being a 20.5-inch overhang. That's okay. You might say, well, what if we did a 11-inch overhang? How would that make the numbers any easier? Let's just see what an 11-inch overhang does. So again, the same thing. We're just going to draw a line over. And before we even draw that box out, we can see that that's a 19-inch. So maybe that's better. Maybe 11 and 19. So you could experiment with this. You could do all sorts of overhangs. You could have the 10-12 be a 14-inch overhang, and that would mean that the 6 and 12 would be a 2-foot overhang. So they're, again, but you have to know what these are ahead of time. So let's say we decided, again, for this to be our solution. And I'll go ahead and sometimes just make a little note like this so that I don't forget. Every house is different, and sometimes I just like to remind myself. So I've got over here on the side my 10-foot walls with the 2 overhangs, and then I'm going to come right over here next to it and do my 13-foot walls, because I don't want to slope up to 13. I want an actual 13-foot plate. So I have these all drawn out, and we know what our overhangs are going to be. So now we know that where we have the 10 and 12, we're going to have an 11-inch overhang. So we can come over here now, and whatever layer you want it to be in. Well, what I always do is I draw my roof plans with a different set of parameters. So I have a R wall for my rafter wall, or my roof wall, and I create a polyline that goes around the whole thing. And then we can turn the wall layer off. Unless I turn off a whole bunch of other things. There we go, that's fine. Now for my rafters, I'm just going to come over here, and I know it's 11 inches. So there's my 11 inch on this side. I also know that even for my 13-foot ceilings, my 10 and 12 pitch side is going to be 11 inches. Again, this is 11 inches. Same on this side, and then we can copy this over, and that's 11 as well. Okay, so we have the sides done. For the front and back, which is the 612, we need to do 19 inches. 1 foot 7 is 19. And then we can copy this here. 19. And copy this here. I'm going to first draw, and then we can go ahead and fillet all of the corners. And don't worry about where we have plates that go up and down and all that. For now, we're just going to do this to get it nice and clean. We're going to draw this entire roof currently as a hip roof, because if you can draw a roof as a hip roof, it's really easy then to make any of them a gable. So we're going to do hips because those are the hardest. So we need to create this hip and this hip and this valley and this hip and this hip, this valley, and so forth. So how do we create, if the pitches were the same, you would just draw a 45-degree angle, and that would indicate that we have an even pitch on both sides. Let's say it was an 8 and 12 and an 8 and 12, but we don't. So we have to create an angled line. The way we do that is we're going to draw one line that's 11 inches long and the other line that's 19 inches long. So which one do you make in each direction? So I always just remember that the lines go in the opposite direction of the roof slope. So we know that this roof here, this, I'll draw an arrow real quick. That is a 6. This over here is a 10. Okay? So if I draw the opposite of that, instead of doing down a 6, I do a 10 here and a 6 here. And then do a close command. That creates the angle that is this hip. When I put it there in the corner and extend it, it's going to come very, very close. You might say, well, why doesn't it hit exactly? Well, because you have to offset this to the inside, and that's not true, sorry. The reason it's not exact is because I don't think these are exact. If we were to take our dimensions and bring the carry the tolerances out, where are my tolerances? Well, oh, there it is, fit. No, that's not it either. Primary units, there it is, sorry. Instead of doing a round off at 1/2 inch, if we were to do something like 1/8 inch, and then the precision is at 1/16, you would see that we're actually at 18 3/4. So if I was actually to do this as a 11 and 18.75, did that wrong. Sorry. If these overhangs were instead of being at 19 inches, it was at 18 3/4 inches. Now watch. 18.75. That's where our difference was. Now if I draw my 10 down and 6 over and close it, this should be almost exact. And there you can see it's very, very close. So that's the reason why. I'm just going to undo all that, but it should be almost exactly to that point. So sometimes you can cheat if you know and just go to that point, but again, we'll just stick with 10 and 6 and close, and that creates that angle. Extend it out a little bit. Erase and erase. We can do a mirror command because we know that the back is also that same 10-foot plate. And then at this point we're going to have a ridge. We can do the same thing over here, and since we've already done the angle, we can steal it and just copy it over here and here, and then fill it. And since this is a 10 and this is a 10, they just join in the corner there, and then we have a ridge that connects these. And then this is going to shoot off into space somewhere, and this is where it gets a little bit tricky, because if we come to the front, we know that all three of these walls have to be 13-foot ceilings, right? So this is easy. This is just a regular hip, and over here's a regular hip, but at some point we go from being a 13-foot wall to a 10-foot wall, and it's right here where they have a room. So what we're going to do is actually have one roof that's sitting up on top of here, and the other roof comes down and hits below it. And the way we do that is, first of all, I just randomly, yeah, that's fine. We will end up with another soffit that comes off the back side. So whatever this distance was, which was 19 inches, we're going to come back here 19 inches. And it comes off here. So again, we've got all of this at 13. I love that same color. And so this is a roof that's sloping up, and this is a fascia board that's going flat. So at some point they are going to meet. The question is where. Well, we've got all this mess going on here. Since these two intersect before anything else does, that's going to create a ridge right there. So again, we've got a plate. This is a fascia board that's level, it's horizontal. This is also a fascia board that's horizontal, but this right here is a roof that's sloping up. So when does this roof here hit this fascia? There's going to be a point where it hits. And you know what, just for the sake of math, I'm going to change this to a 12-foot ceiling because I want it to be a little bit more obvious where these things hit. It's a 2-foot difference. So how do we know where this roof comes up and eventually hits this piece of fascia board? Well, this is where math comes in. We know that this is a 6 and 12 pitch right here. So what that means is that for every foot we go back, it goes up 6 inches. Well, we know that we're actually going to go up 2 feet because we're going from a 10-foot ceiling to a 12-foot ceiling. So we know that our up is 24. That means our rear is 48, and that's our 6 and 12 pitch. So again, we're from this point here up to this point here is a 2-foot increase. That means a 4-foot change in front to back. So we take this fascia board and we go back 48 inches. Okay? And at that point where that hits it is going to be the point right here where this fascia board hits this roof. So again, it was a 2-foot difference in height, 10 to 12. In fact, what we would have normally here is a designation that would say like 10-1 plate, and another one here, just so that we don't get mixed up here, that would say (12-1 plate. Okay, so those are our 2 plates. So they're, as long as these fascias are equal, which they are. See how they're the same? That's why we did it that way. Whoops. As long as those two are the same, then from this point, from this fascia to this fascia is a rise of 24 inches. And on a 6 and 12 pitch, that's 48 inches. So again, 48 inches back. What do we do at that point? We take this same hip and turn it into a valley right there. Okay, what's going on here? We don't know yet. Let's just trim this off, not worry about it. This is a ridge up high. We need to have another hip coming down. So we've got all kinds of things happening in this area. We also need to figure out where this roof here intersects with this fascia. Again, this fascia board is horizontal. It doesn't go up and down. It just goes straight on a horizontal plane. But this roof next to it is going up, 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 up. Again, we have a 10-foot plate here, and we have a 12-foot plate here. So we know that there's going to be a 2-foot increase from this point to where it hits. Once it goes up 2 feet, it's going to hit this. I can kind of show you here what that looks like, because here's the fascia board below, and it's got to go up. No, we need to make it a 12-foot plate. It's got to go up 2 feet. And once it goes up 2 feet, it hits this fascia board, the top edge. Well, this is a 10 and 12 pitch roof. So the way we have to do that is take a calculator out. And the ratio of 6 and 12 is easy because it's a 2-to-1 ratio, but 10 to 12 is a little different. So what we do is we have to create a fraction. 10 divided by 12 is 0.833333. Okay, you just got to remember that or save it as an integer or a component for learning the math. We know that we're going up 2 feet, but we're going to go over a certain distance. So what we do is we do 24 divided by that integer, which is 0.83333, and it becomes 28.8. So we're going to copy this over, 28.8. That point right there is the spot right here where this roof overtakes this soffit. So again, to do that math, the formula is basically the rise divided by the slope equals the run. As long as you can get that figured out, that the rise divided by the slope, so the rise is 2 feet, or 24 inches, 24 inches divided by 0.83333 equals 28.8. That's the math. Okay? When we did this one over here, just to prove that it works, 24 was the rise. Sorry, I meant to grab this too. The slope was 0.5 because 6 divided by 12 is 0.5 equals 48. If you punch that into your calculator, 24 divided by a half of 0.5 equals 48 inches. So that's how the math works. Trust it. It never is wrong. And again, if we had forgotten what we were doing here, we know that we've got a 10 and 12 and a 6 and 12, so we know that this direction is the 10, so I'm going to draw 6 inches, and this direction is the 6, so I'm going to draw 10 inches. You do the opposite, and you can see it's the exact same. So that happens to be the same slope as these, and that's why I said earlier you can just steal it. So now we've got all these hips and valleys kind of heading off in different directions. And this is where you have to start just extending them until, so basically you'd say, well, what's going to hit first? These two or these two? And you can see that these hit earlier. These hit before those two do. So that's the spot that's going to hit. I also will go ahead and draw little arrows because they help me figure out the slopes. And that's not an arrow. Try that again. Because sometimes you can get a little bit bogged down in, oh, which way is this roof going? So we know that's going that way. We know this is going this way. And these are just temporary, just things that I put here while I'm designing the roof. We know that this roof is also going here, but then this one here is going this way. This roof, again, is going this way. So let me erase that for the moment. Where is this one headed? Well, we also know that there's a roof here as this comes over that's aiming down. So what we're going to end up is between this roof and this roof is a dead valley. That means it's where water would just sit. And if I draw this line this way, you can see there it is. A straight line on a roof either means a dead valley or a ridge. Okay, obviously ridges are good, dead valleys are not. So at some point where this roof comes down and this roof comes down, there's going to be a valley, a dead valley. I think that this one is going to come here. And you can just start to experiment and play around with things, and you'll see eventually that if you play around with enough options, they will all connect exactly. And somehow we got off by 1/8 of an inch, and I'm not sure exactly how. So somewhere one of my connections is not quite right. It might. Oh, you know why? It's because I shortened. The 28.8 should have been something more like 28.815 or something. So if you really want to get exact, just push this here. This goes here. That goes there, and there. That's exactly right. So now you can look at all the arrows, and you can see that if there's an arrow going left and down, that again you can check that angle by saying that the down should be 10. It's the opposite of what it is, and the right should be 6, which is the opposite of what it is. And look at that, the angle is the exact same. That's how you check to make sure everything's right. So what we have on this particular roof is a gigantic dead valley. Not good, but wasn't really thinking about that when I created the example, or this teaching exercise. So what we would end up doing in this case would be putting in a big, what we call a cricket, which is basically another roof inside of here that you really can't see from the street, you can't see from anywhere, and it looks like that. And you might say, well, what are the slopes going to be of that? Well, there's a way to find that out too. We know that if this is a 6 and 12 pitch, and I draw a 6 this way, that whatever I draw here is the other slope. So this right here is 3.5. So this is a 3.5 inch 12 pitch. Okay, so there's always a way to figure these things out mathematically. For now, we'll just leave it at that. And that is what the roof would look like with 12-foot plates, 10-foot plates, 10-12 pitches, and 6-12 pitches. If you have any questions, just ask it in the comments, and I'll be happy to answer them.